many of these functions do take that OPD table that we generate here to do some of the trending, but in general, some of the trending that I show you already, there are different ways, there's different functions where you get the same information. So this is just to show you and basically for you to have this in the notebook and you can play around with this at your own time. But for instance, I can see that time series, if I really don't want to have the entire, 3 years of the observatory, 2.5 years, I can do that for a particular month. So they give you similar. I can also just show you the wavefront drift. So basically the drift between the times. And you'll see that in this case, I'm doing a from early this year, 2024, to this past weekend or last week. And you see that early on the year, we have some events. Some of these, like this large one here at the end of February, is the one that have that memo of this large correction that needed to apply to the telescope that we apply quickly. But in general, many of these, you can see that then that we were able to correct after a day or so. And in the past month or so, the telescope, you see the drift has been fairly stable with a few changes here. And some of these changes doesn't necessarily mean that there is a need to apply a correction because some of the changes on the mirror sometimes they revert back to their previous position. So we may have some instability and it can actually go back to the point. I'm not trying to minimize some of these events that happen. I'm just trying to give you the idea that if something happened, we can quickly react to correct those. And after correction, we can recover the same performance that we have before with the telescope, as long as these are all events related to small changes on the mirrors. Again, this still uses the OPD table, but I can focus and say, well, during this time period, how was the telescope performance? You can have a histogram that tells you during the majority of the time, we were in a really good position in terms of the global wavefront error that we observe. And here I'm just focusing. I wanted to mention that remember that for the phase maps, we have basically two products where we have the observed phase map that includes the wavefront error contribution from the NIRCam instrument, because that's what we're using to calculate the phase map of the telescope. But we can also remove that, as I showed you in the first few cells, we can remove that and have the OT only, basically the telescope only wavefront error. And this is one of the parameters that we can use here. And you can see that since April, we have had a very small drift. And this is the normal drift of the telescope that you would expect to see. And the past month, really, or so, a few weeks, we have been very flat in terms of changes. These have almost no impact on the observed PSF. Changes on full width and circular energy fraction, talking about a couple nanometers of global wavefront error, really have almost no tangible effect on the observed PSF. This is a case where you can start running your cell, which is one of the cells that you can run that doesn't need the OPD table. And what is going to happen is that I want you to try this with a particular program that you have. If you don't have any program in mind, or if you don't have any program at all, just run the cell as is. And this is a program that that was observing the sky at different times. It's a large program. So it'll give you an idea on for a particular program. None of these manual setups that I did this before, where you set up the times or the time range, all those things are taken care with this particular function. So trying to run that in the notebook by yourself, and this is sort of like a summary of everything else that I've been mentioning. You still have your global wavefront error, and you can still see how things change based on your observation. And you have your visit ID. Remember that for your program, you have a visit ID that have the information of the program ID and the observation and the number of action, the activity inside the visit that you were scheduled. So this is a cell that is not on the notebook, but I want you to copy paste and run that using your own program. I didn't mention this before, but we don't necessarily need to run every single cell in this notebook. This is just so you have the information on how to do this later. So I just want to mention that you can, for instance, load manually your OPD here. Oh, I have a remote disconnect sometimes. I have had this in the past, and this is particular to this platform. Okay, I just rerun that cell again. If you know, remember that OPD file that I showed you before, or if you know the name of the particular phase map that you're trying to use, you can load that directly and do your calculation and get some very convenient functions. This is before. We have our 4 WebbPSF extensions. The last two, which have the geometric distortion effects. So basically, when you change the positions of the telescope, so it gives you a field dependence on your simulation of the PSF. These are the ones that do have the detector effects. Typically, the detector, the last extension is the one that you want to compare with your observations, right? Unless you're working on oversample PSF for particular cases. Let's say that you are creating an empirical oversample PSF, an ePSF, then you can, or you have a good jitter pattern that allows you to create an empirical oversample PSF, you may want to use the other extension. And there are just a few convenient functions that allows you to visually see initially how the simulation went.